Okay, so we just found the shear and bending moments by slicing it a whole bunch of times, like coming in through slicing it a whole bunch of times. So that works. It's can be kind of less pleasant. So there's other ways to do it. And so what we're going to note here for a concentrated load, that the shear is constant, right? It's constant in between each concentrated load. So here we got this. So we have, so say these are the supports, 40. So you end up with 60 going down, 60 going up. So it's all in equilibrium. Okay. So if we cut it right here at point 1, if there's 20 going down, there's going to have to be 20 going up. And remember, that is going to be a negative. So we have negative 20 coming down until we hit this next point, swap up to hit that point, and so on, right? And so we can find these values based on the concentrated load. So these are pretty straightforward to find. Okay, the bending moment varies linearly based on the curvature of the shear diagram. So what does that mean? Well, it means that we can, as it says right here, use the areas of the shear to calculate the values of the bending moment. So this is the next step to make life a little bit easier. Okay, so what am I saying? So the bending moment here is going to be 0, right? There's no applied external moment here or anything, so it's going to start at 0. Now I can look at the area under this curve. So what is the area under this curve? It is 20 times 2.5. So 20 times 2.5 is 50, right? So this is going to change 50. It's going to go from 0 down to negative 50 because it's a negative area. Now, what is the area of this part right here? It's at 26 times 3. So 26 times 3, 25 times 3 is 75, 76, 78, right? So it's going to go from here, it's going to increase by 78 because this is positive, right? So I'm going to go up 78. So 50 of it is up to 0, and then up to here to positive 28. And then lastly, this area here under the shear curve here is 14 times 2, so that's 28. It's negative again, so it's going to go from that 28 down to minus 28, which brings us back down to 0, which is what it should be doing for us. We should be back down at 0. So there you go. This is using the areas of the shear, the areas under this curve, to calculate the values of the bending moments. So given that, let's go look at 7.2 again, but this time we're going to do it better, bigger, better, yay! And also we're going to look at example 7.3.